Hello everyone, we're the Brain Cells, and today we're going to be explaining and thoroughly diving into the project of Arduino. We will be teaching you step by step on how to code, how to assemble, and explain each parts and their importance in the projects. In the process, my group mates and me will explain it to you on how it's processed. We have Sir Hans, who will be editing the videos. We have Sir Ace, who will be explaining how the assembly is work and thoroughly strategize. And we have Sir Galib, who will explain the parts and its importance. And me, yours truly, will explain the code and thoroughly dissect it to easily teach you on each of its importance. Without further ado, let's go into it. The Brain Cells presents Arduino Project 30 Motor Fan.
The first one is jumper cables, short connecting wires with male ends used for quick prototyping. And the second is resistor 220, current limiting device for LEDs or small loads. And the third one is push button, a simple tactile switch used as a user input in circuits. And the fourth is relay, electrically controlled switch for turning high voltage or high current device on and off using Arduino. And the fifth is 130 motor, small DC motor commonly used in toys and basic robotics. And the sixth is fan, propeller attachment for the 130 motor used to demonstrate airflow. Lastly is 5mm LED, a single color light emitting diode for basic on and off or indicator functions.
Hello everyone, my name is John Stephen, and today I'll be the one to explain how the code works in Project 13. So, in this project, we're using a button and a relay to control a fan. Firstly, we set up our pins and variables. The button is connected to pin 2 and the relay is connected to pin 3. Over here, we keep track of two things: the current state of the button and the last state of the button. This is important because buttons often produce noise when pressed, like tiny flickers between high and low. To handle that, we use a technique called debouncing, which basically means waiting a short time. Here is 50 milliseconds before deciding if the button press is real. In the setup function, the Arduino prepares the pins. The button pin is set as an input to detect presses, and the relay pin is set as an output to control the relay. Finally, digital write, relay pin, and relay state ensures the relay starts in its initial off state for consistent operation. Next, in the loop function, the Arduino constantly reads the button state. If it notices a change from the last state, it records the time. Then, after the debounce delay, it will check again to confirm the press. If the button really was pressed, the program flips the relay states. If the fan was off, it turns on, and if it was on, it turns off. Finally, it updates the last button state so it can detect the next press. So, in simple words, every time you press the button, the relay changes state and controls the fan, just like a toggle switch.
Number 13, the DIY fan. The components you will use are push button, jumper wire, a relay, fan, motor, resistors, and the Arduino Uno together with 5mm LED. So here we attach the push button, and we will proceed to attach the jumper cables to get the energy. So we will attach it on 5 volts. So this project is controlled by the relay and push button. It's the main turning on and turning off of the electric fan or the mini fan. So when you press the push button, it will turn on, and if you press it again, it will turn off. So we attach the relay and the jumper cables, and now we will proceed to attach the another jumper cables to the ground area. So we'll now place the resistor. And now we will attach the motor and mini fan. So as you can see, if you press again the push button, it will turn off the mini fan. And that's it.